A, B, C, and E are the link lengths, and C and E are meant in line. It's just they are aligned along this particular line. Okay, so the first task is to define and draw on the figure, define and draw on the figure DH frames, and write the relevant parameters, DH parameters. So I'm giving you like a couple of minutes, like 3 minutes at most, so that you can draw the frames on your papers and DH parameters as well. Time is ticking. And we'll compare our results. The base frame is given already. Prismatic joint. So we usually take the base frame and the frame of the first joint together. So prismatic joint has its frame already assigned. So start with this one. Okay. All right. Okay, I think it's clear that the Z1 is towards us or into the plane. We usually take it towards us, right? Z1, which is here, is towards us, right? Because it's a revolute joint. And the axis of rotation of this joint is into the plane or out of the plane. And I usually take X1 in this direction. Okay, this is my X1. So I don't need to show the Y1. Let's move on to the next frame, next joint. Okay, Z2 again is towards me, and X2 will be in this direction. X2, and we don't need to show the Y2 axis. Pardon? Okay, so let's move on to the next joint, which is a revolute joint again. So we have two options. This is axis of rotation, right? This is axis of rotation. So I can choose this one or this axis as my Z3, right? Let's say this is my Z3. I'm choosing this one. Z3. What about X3? Doesn't work. It doesn't work. Out of the plane into the plane doesn't work. So it definitely.
We should remove the origin of O3.
Absolutely, absolutely. So we have to move it. We have to move the third frame so that X3 can intersect the extension of Z2. And I think this is a good. Which one is it? I mean, Z3. I'm choosing this one this way. This is my Z3, and perpendicular to Z3, I have X3. I guess, yes, this way. This is my X3. And for clarity, I am going to show the Y2 axis as well, which is perpendicular to X2. This is Y2, perpendicular to X2. This is X3, perpendicular to Z3. All right. Okay, good. What else do we have? The end effector frame, which is basically the copy of Z3 in this direction. All right. Z4. What about X4? It should be perpendicular to Z3 and Z4, and it should intersect the extension of Z3. I think it'll do the job. Oops. Okay. Parallel to parallel to x. Oops, x4 is parallel to x3, obviously. Okay. I'm sure everyone follows me. We're on the same page, and no one has any objection. Do you have any objections or anything unclear? Okay. Now it's time we structured the edge parameter table. Just because we have 4 joints, we are going to have 4 rows. And 1, 2, 3, and 4. Okay. Shall we start? Okay, think about this, and we can check our results. Theta, di, alpha I, and ai. All right. I think we can start with thetas. And the joint space is, let me just write it down here. My joint space will be, in other words, the joint variables will be d1, theta 2, theta 3, theta 4. These are variables, not constants, but variables. I'm talking about these variables. All right, theta 1. What is theta 1? What do you think it is? The question for theta 1 was around z0, how much we have to rotate x0 so that it can align with x1. What is the answer?
0.
0, because after actuating the joint 1, okay, the arrow was aligned. The angle between these two is 0 all the time, so it's going to be 0. 0 is a variable. I'm writing it in red. Okay, what else? What about theta 1? Theta 1.
Theta 1, 0. Theta 2. Theta 2.
Oh, okay, theta 2. Yes. Theta 2. What is theta 2?
Theta 2.
Yes. It is theta 2, and it's a variable. I don't know why I said bilmiyorum niye dedim ki 0'ı ben de kırmızıyla yazdım çünkü variable'dı. Neyse. Anyways, what else? Theta 3.
Theta 3. Theta 4.
Okay.
They're variable.
Okay. For joint 3, do you think we have to add something else?
No.
Let's ask ourselves this question. If you write this in the exam, I'll just take it correct. Don't worry, I'll accept it as a correct answer. But just to make sure that everyone has this, let's say, a rule. Okay. So for theta 3, the question was around z2, which is towards us, right? How much I have to rotate x2 to make it aligned with x3? What is the angle between these two x-axes, let's say?
90 plus theta.
Yes. 90 degrees plus theta 3. Okay.
Yes.
So if you provide this answer, simply theta 3, I'll accept it. But I told you, different literatures treat it differently. If you're able to write it down this way, just write down it this way. But both answers are okay for me. Don't worry. Let's move on to the next parameter, which is d1, di's. What is d1?
How much?
Oh yes.
How much to move along z0 axis to align the origins of O1 and O0?
Yes. And the answer is
D1.
D1, and it's a variable. It's a variable. D1 is a variable. Okay. What about D2?
D2, 0.
0, because there is no need for any translation.
Yes.
D3?
Also 0.
0, because there is no need for any translation. And D4, let's see D4. So along Z3, which is in this direction, right? How much I have to move this origin to make it aligned with this origin? The answer is
C plus E.
Plus E.
Yes.
That's it. And it's a constant. C plus E. Okay, let's move on to the next parameter, which is alpha. So alpha 1. What is the question for alpha 1?
How much to rotate about x1 to align the z0 and z1?
Okay, how much?
How much? 90 p.
Yeah, positive
90.
pi by 2.
90.
Yes, positive 90 degrees, because around x1, I have to flip the z0 axis by 90 degrees to make it point towards me, which is the direction of z1. Okay, x'in etrafında z0'ı yıkmalıyım ki z1 istikametine bana baksın. So the answer is going to be positive pi by 2. Okay, what is alpha 2?
0.
0, because they're always parallel to each other. Z1 and Z2 are parallel to each other. Z3?
90 pi over 2.
Yes, like, where is 3? Yes, here, around x3, how much I have to rotate Z2? Where is Z2? Oh, yes, here it is.
Towards
Z2, yeah, to make it aligned with Z3.
Exactly. Positive pi over 2.
Positive pi by 2. And last one, alpha 4? Around x4? Yeah, 0. There is no need for any rotation to make Z3 and Z4 aligned. Okay, let's move on to the last parameter, which is A. A1.
How much to translate along x1 to align the origins of O0 and O1?
Yeah, that much.
Yes.
The answer is
A.
And it's a constant. Okay, what about A2?
A2, it's B.
In this direction, exactly.
Yes.
How much I have to move this origin to make it aligned with this origin? The answer is B. It's a constant 2. And what is the next? A3, yeah, they are aligned already. The origins intersect, 0. And A4?
Also 0.
Yes, because in this direction, there is no need for any translation. They are aligned here, so 0. And this is the DH parameter table. Okay, hopefully there is no questions. Yes, we can move to the next one. Unfortunately, I cannot hear myself. One of my ears does not work properly. I cannot hear myself. So calculate the geometric Jacobian of the manipulator arm. We have covered geometric Jacobian, haven't we? We have covered this one. Tomorrow we are going to cover analytical Jacobian, which is slightly different from that one, from this one. Yeah, let's try to find it. Let's try to find it. Whenever you get a question on geometric Jacobian, you have to write down the equation. So J of Q, which is geometric Jacobian, right? Will be dimension of what? What is the dimension of this matrix in this particular case? Geometric inspector. My goodness. Geometric Jacobian. What is the dimension for this manipulator?
3.
3. It always has 6 rows and
the number of joint.
Yes, it will be a matrix of 6 by 4. 6 rows and 4 columns. Okay. Anyway, that's okay. So the first column will correspond to the prismatic joint here. The next ones will be revolute joint, let's say, contributions. Okay, so it's going to be the matrix. Prismatic joint. And the first three rows basically contain all the contributions. I'm talking about this one, right? This particular part will contain the contributions of the prismatic joint, okay, on the linear velocity of the end effector. All right, and according to our lecture, it's going to be z0 only. And prismatic joint does not have any contributions on the angular velocity of the end effector. That's why it's going to be a zero vector. Okay, then revolute joint, which is the second joint of the arm, it's going to be z1 cross product end effector position minus p1, and angular velocity will be z1. Contributions of the angular velocity of the second joint on the angular velocity of the end effector will be z1 only. The same applies here. z2 cross product p minus p2. Here we have z2 only, and z3 cross product p minus p3, and z3 here. Do you start remembering this? We've done it many times in the classes. Does it look familiar?
Yes, yes.
Okay. So which parameters do we have? We always say that z0 is 0, 0, 1, p0 is 0, 0, 0. What else do we have? Do we know z1? No, z2 is unknown, z3 is unknown. We don't know any of these. We don't know p, p1, p2, and p3. We have a lot to find. We have a lot to find, and we are going to use geometric inspection to find them out. So it's going to take time. Help me. Help me. So let's start with z's. What is z1? I'm just so curious how many of you can answer this question. What is z1? Have a look at this picture and tell me what z1 is. By the way, if electricity is cut off, okay, don't log out. I will try to use my cell phone, cellular data, whatever that is called, megabyte nistfadlayacağım ki to get back to the class. Okay, I mean, like electricity is cut once a day, so there's a possibility. Okay, what is z1? If z0 is 0, 0, 1, 0, 0, 1, what is z1? Any guesses? Any random guesses? Just you can throw any answers you want. All right. We choose the z0. Sorry. z1, z2, z3, zn. Okay, as a projection of the unit vector on the base frame. Okay, what is z1 here? Z1, like imagine you have a unit vector. Imagine you have a unit vector whose origin is in the origin of O1. Okay, and it lies on the z1 axis. Okay. Bir de bağcı bir vektör fikirləşmə, belə bir vektör fikirləşin. Z1 adı belədir. Okay. Belədir. Və o yıxılıb uzanıb Z1-in üstündə. Hansı ki bizə tərəf gəlib Z1 aksisi. Və Z1 belədir, qrafa baxanda aksis. Z1 yıxılıb yatıb burada belə. I have to find its projection here Okay. Bunun kölgesini tapın. X sıfırın üzerinde, Z sıfırın üzerinde, bir de Y sıfırın üzerinde. And it will give me Z1. Gelin yoklayalım onu. Heh. O balaca deməli unit vector. Uzanıp bir okun istikametinde. Okay. What is the projection of that unit vector along x0? 0, düzdür. Razısınız.
Bəli, bəli.
0. Okay. What is the projection of that small unit vector along y0? What do you think? It's parallel. It is parallel to y0, right? It should be either 1 or -1 if it's in the opposite direction. What do you think is the answer? Y0 hara taraf gelir? İçeri doğru gelir. Düzdür. Y0. Ama o ise bize taraf gelir.
Yes.
-1.
-1.
Again, let's ask the same thing. What is the projection of that small unit vector along Z0? 0. Düzdür. Ona perpendikulardı. Hiçbir pay eksesi yoktu.
Yes.
So it's going to be 0 as well. That's it. So Z1 is 0, -1 and 0. Bize rahat. Yani
Onda tapdığımız vektoru unit vektor kimi götürürük. Onun proyeksiyasına göre yazırıq.
Bəli. Deməli, Z0'ın üzerinde unit vektor uzadın. Onun proyeksiyasını həmişə base frame'de aktarın. Bir de Z2'nin üstüne gelirik. Z2'ni aktarmaq üçün. Z2 oradadır, buradadır, düzdür. O da görürsünüz ki, onun başına gelen, bunun başına gelen, Z1'in başına gelen, onun başına gelecek. Çünkü paraleldir birbirlerine. Bunu da üzerinden vektör yıkın, uzadın. Z2 adlı. O böyle bir, Z2 adında böyle bir unit vector uzadın. Onun proyeksiyasını tapıb base frame'de. Bu bize Z2'ni verecek. Deməli, Z1 Z2'ye beraberdi. O da beraber olacak 0, -1, 0'a. That's all. Çünkü onlar birbirine paraleldi. Z1 ile Z2 tapıldı. Right? We have Z1, we have Z2. Let's find Z3. Okay, aynı şey. Yani bu daha böyle göze gelen olacak. Ama bir unit vector böyle uzadıram. Böyle bir yaşam bir rengi right? Böyle bir unit vector uzadıram bura. Adı da olsun Z3. Papalı Z3. Unit vector. Bunun proyeksiyasını aktarmalıyım, tapmalıyım. Bak burada. X0'ın X0 yani böyle eləyək. But böyle bir şey. X0, imagine this is your X0. I'm kind of sliding it here, right? So what is this angle? What is this angle?
Theta 2 plus theta 3.
Absolutely. Okay. So projection of this small unit vector along X0 will be cosine of 2, 3, right? Cosine of 2, 3. Cosine of theta 1 plus theta 3. What is the projection of this guy on Y0? 0, right? It has no projection on Y0.
Yes.
What is the projection of this small guy on Z0, which is this one? Sine of
0 again.
No. Çıkacak amel gelir, düzdür. Z0 budur.
Hə, sine olacaq.
Yes, sine of theta 2 plus theta 3. That's it. And Z3 is determined as well. Z3 is cosine 2, 3, 0, and sine of 2, 3. That's it. So Z, the same vectors are derived. Okay, just I hope it's much better now to determine them geometrically. Okay, because most of the times homogeneous transformation matrices are not given to you. If such matrices are given, you can actually derive them from those homogeneous transformation matrices. But in our case, they are not given. We have to use geometric inspection to find all these things.
Can we look Z3?
Oh, yes, of course we can. So I am going to I am trying to find a projection of Z3 here, because this is x0, right? And this is θ2, because these are parallel lines, and this is the intersection of it. So θ2 and θ2. So in this small rectangle, the projection of this Z3 will be cosine of θ2 plus θ1, θ2 plus θ3. Okay, so the same applies
Okay,
here.
thank you.
Yes, okay, yes. You're welcome, you're welcome. What about P's? What is P, P1, P2, P3? Again, geometric inspection. Let's see it. Let's start with P1. P1. It has three components, doesn't it? So P1 is here. P1 is here. So what is the let's say projection here, right? Px1, Pz1. I'm finding this, and Py1. Okay. So what is that? Exotic prices ne olur bu noktanın? A, right? A. I hope everyone agrees. A. What else? Along the projection of O1, okay, along Y0. This is 0, right? It has no projection, I guess, right? So it's going to be 0. What about Z? It's going to be D1, which is a variable. D1. This is my P1. Let's move on to the next P, P2. So I'm finding this one now. The projection of this origin along x0 is A plus this distance, which is B times cosine of θ2. Okay, I hope everyone agrees. A plus B times cosine of θ2. Projection, where is that? Projection of this origin along y0 is going to be 0. Okay, and projection of this origin here will be d1 plus this distance, which is b times sine of θ2. Okay, so along y0 is going to be 0, and here we have d1 plus b times sine of θ2. Let's move on to the next one, P3. P3. It's the same, right? Because their origins intersect. Whatever we wrote for P2 is going to be the same for P3. Okay, so let me write down. P3 will be the same as P2 because their origins intersect. Because we are finding the same vector. Okay, vector P2 is this one. Vector P3 is this one as well. So they are equal. They are identical. So what else? Oh, yes, and finally this one. End effector's position. P. What is that? Let's see. So along x, we're finding this one. A plus b times cosine of θ2 plus this distance. Okay, which is c plus a times cosine of θ2 plus θ3. Okay. Yaxşı. Okay. Həmişəki elədiyiniz şeydir yəni. Deməli, x üzərində olur nə? A üste gel. B vurulsun. Kosinüs teta 2 üste gel. C üste gel. E vurulsun. Kosinüs 2 3. Y üzerinde tabii ki sıfırdı. Planar bir robotik manipülatörümüz olduğuna göre. What about the what is that? What about the projection of the end effectors origin along Z? Okay, D1 plus this distance B times sine of theta 2 and C plus A times sine of theta 2 3. Okay, as expected. B times sine of 2 plus C plus E times sine of 2 3. That's it. How amazing. Good. Do you have any questions so far? That we can, before, calculating Jacobian matrix, you can ask your questions if you have any. All right. Now, let's substitute all these things into this matrix. Copy. Copy. All right. So J of Q becomes Z0 is 0 0 1 and 0 vector is 0 0 0. This is the contributions of the first joint on the velocity of the end effector. Okay, so yes, we are going to analyze it even more. So Z1, where is Z1? Yeah, Z1 is 0 minus 1 0 cross product P minus P1. P minus P1. Okay. P, A's, I guess, are cancelled. D1 is cancelled here. And Z1 is 0 minus 1 0. Okay, what about Z2? Z2 is 0. Z2 is, what is Z2? Yes, 0 minus 1 0 cross product P minus P2. So these are going to be cancelled. We have all of this here and this one here. And 0 minus 1 0 here. And finally Z3, which is cosine 2 3 0 sine of 2 3 cross product P minus P3. Oops, yes, the same thing. Cos C plus E cosine 2 3 0 and C plus E sine of 2 3. And we have 0 minus 1 0 here because Z3 was cosine 2 3 0 and sine of theta 2 plus theta 3. And this is the matrix, the whole matrix. Okay, let's not be lazy to calculate it. 0 0 1 0 0 0. Let's multiply this. Oh my goodness. You know what? Eliajuk minus B minus minus what? B2 neydi? B2 ne yazmışım ona? B sine of 2 plus C plus E sine of 2 3. Okay. Minus olmalıydı. Okay. That's it. Then 0 here and minus b cosine 2 minus c plus e cosine 2, 3. And 0 minus 1, 0 here. Okay, let's move to the next one. Minus c plus e sine of 2, 3. Then 0, 0. And multiply this and minus this one. And it makes it positive. It should have been positive as well. See the amount of demersives. Oh, man, you guys are terrible. 0 minus 1 and 0 here. Oops. And the last row, the last row is multiply this one, okay, 0. Multiply this one, multiply this one. As you can see, it's going to be the same thing. C plus E times cosine times c sine minus c plus e sine times cosine, so it's going to be 0 as well. What times minus this times, okay, 0. And cosine 2, 3, 0, sine 2, 3. That's it. This is the Jacobian matrix for the given manipulator. Bayağı burada şoka birisi diye düştüm. Bunu buna vuranda bilirdim ki 0 edir. Çünkü bunun end effector'ın linear velocity için hiçbir contribution yoktu. Bunu theta 4'ü ne kadar fırladırsa fırladın. Bunun deməli end effector'da bunun end effector'ı bu bazada heç bir linear velocity'si əmələ gəlmir. Çünki onu translate edə bilmir. Translation baş vermir bunun hərəkəti ilə. Translation yoxsa taptası yoxsa elə deməyim. Yəni bunun hərəkəti heç bir translation yaratmır deyə. Burada linear velocity söhbət gedə bilməz. Ona görə şoka düşdüm ki, necə bunun contribution'ı meydana çıxdı. Sən demə bunlar eyni alınırlar deyə 0 girmiş. Doğrudan da 0 gəldi. Belə. That's it. That's it. So what is that? What did I get? What is the geometric meaning, physical meaning of this matrix? What does it tell me? Can you just let me know? What is that? Bakın kim var burada? İyi. Alt for 4. Burada yazırsınız. How do we derive from transformation matrix? How do we derive them from transformation matrices? Well, okay. If you are given transformation matrices, for example, presumably it's going to be something like that. A1 to 0, it's going to 0, 0, 1, 1, 0, 0, and something like that. I don't know. It's not going to be a matrix, but still. Okay, it's not going to be a correct transformation matrix, but a rotation matrix or transformation matrix, but still. And then we have BAX here and 1 here. It's a typical transformation matrix structure, right? So if you are asked to find Z1, you are supposed to have A1 to 0 first. Like you have to calculate from the DH parameter table, okay? And you have to derive this matrix, this particular homogeneous transformation matrix. And this matrix gives you Z1 and P1, okay? If we had the transformation matrices given to us, o görəcəkdik ki, bizim P birimiz, buradakı P birimiz A0, D1 və burada yerləşəcəkdi. And our Z1 would have been here. 0, -1, 0, okay? So it gives us, it's such a great tool to derive all these things from, okay? But it's no surprise because this is elədiklərimiz var, bunlar hamısı. Aslında bunlar özü də məsəl üçün, bunlar özü rotation matrisi deməkdir. Yəni rotation matrisimiz nə deməkdir? Məsəl üçün, belə deyək də, Z1 nə deməkdir? Z1 deməkdir ki, bu Z1. Orada olan unit vektor bazı frame'də necə orientasiya olunur? Yəni Z oxundakı unit vektor və buradakı Z oxundakı unit vektor bazıdakı frame'də proyeksiyaları nədir? Orientasiyası nədir onun? Həmin unit vektorun. Buradakı Z-nin deməli orientasiyası nədir burada? Hansı ki, rotation matrislər bizə bunu deyir. Rotation matrisinin 3-cü sütunu onu bizə deyirdi. Yəni, bu surprising olmamalıdır və deyildi. Mən əminəm ki, hiçbiriniz üçün deyil. Və yaxud da bu P'lər. Bunlar da surprising bir şey deyirlər. Bunlar Geometric Inspection'da, Geometric Inspection neydi? Daha doğrusu biz həm Transformation matrisini tapırdıq, düzdür, həm də Geometric Inspection'da tapırdıq. Və eyni şey gəlib çıxırdıq. Belə, yəni, budur məsələ. Hər iki üsuldan istifadə edə bilərik. Yüzümüz çatır. Sonra niyə bir şey deyə bilmirəm bunu. Teacher, I have a problem related to sound. So I cannot, oh yes, with the help of a microphone, I have a question. How did you find Z1 with the help of geometrical visuals? Okay, can we also draft information? Okay, okay. No, I mean without it. Yes, Farman, we actually, we found the Z's, like Z1, Z2, Z3, using no transformation matrices. We did that. Mən Azərbaycanca qayıdacağım, onu təzdən deyirəm. Bir dənə Muhammedə baxım. Can we also derive transformation matrices? Of course. Yes. Əlbəttə. Yəni transformation matrisi DH table'dan tapırsınız. Biraz uzun yol olacaq, amma eyni şey gəlib çıxır. Okay, eyni şey gəlib çıxır. Ona gəlmişə biz differential kinematikayı həll edəndə birinci direct kinematikayı həll edib, sonra keçib differential kinematikaya. Yəni görürsünüz ki, bizim o DH parametrimiz var idi ya, burada. Onu aslında differential kinematikini tapmaq üçün istifadə eləmədim. Amma həmişə qəşəng praktik, common bir practicedir ki, birinci DH parameter table tap, qəşəng bunların hamısını qeyd etməliyik bunları, frame'ləri. Ondan sonra keç differential kinematikaya. Yəni bir sözlə, ya Geometrical Inspection'ı istifadə edin, ya da ki bundan istifadə edin və sizin o aydan ay çox birə olan relation'ımız vardır. Bundan istifadə edərək hamısını bir-bir tapın. Orada nəyi tapırsınız? 2-dən 1'ə, 1-dən 0'anı, 3-dən 2'yani, 4-dən 3'yani falan tapırsınız. Amma sizə lazım olan nədir? Yuxarısı 0 olanlardır. Çünki hər şey buna əsasən baş verir. Yəni sizə 2-1 lazım deyil. Sizə 2-0 lazımdır. 2-0 tapmaq üçün də siz 1-0'ı vuracaqsınız 2-1'ə. Okay? Sizə 3-2 lazım deyil. Sizə 3-0 lazımdır. 3-0'ı tapmaq üçün siz 1-0 vurursunuz 2-1'ə, onu da vurursunuz 3-2'yə. Belə bir şey. Tamam. Bunu Azərbaycan deməliyəm. Onsuz da həmişə mix edirəm dilləri. Deməli, Geometric Inspection'ı tapmaq istəyiriksə, Fərman, deməli, belə rahat deməli deyə, mən bu üsulda şey deyirəm. Uşaqlar da istifadə edəndə məncə çaşmırlar, yəni xoşları gəlir. Mən də xoşum gəlir, çünki həmişə işə yarayır. Amma belə deyə də, terminləri falan səhv istifadə edə bilərəm. Deməli, məsələn, Z1'i tapmaq istəyirik, düzdür? Z1 tapmaq nə deməkdir? 1-0'daki, üzr istəyirəm, bu transformation matrisin 3-cü sütunu tapmaq deməkdir. Bu 3-cü sütunu tapmaq üçün biz nə edirik? Bir dənə unit vektorumuz var. Tutaq ki, bu jointə mən yandan baxsam, bu mənim Z1 aksisimdir, düzdür? Mən balaca bir dənə unit vektor çəkirəm onun üzərində. Onun da adı olacaq Z1 hat, unit vektordur. Həmin bu unit vektorun X0'daki proyeksiyasını tapıram, Z0'daki proyeksiyasını tapıram və Y0'daki proyeksiyasını tapıram. Onlar tapa-tapa hamısını belə doldururam. İndi gəlin baxaq. Təsəvvür edin ki, Z0, Z1 daha doğrusu bizə tərəf gəlib. Bizə tərəf gəlibsə, X0 üzərindəki proyeksiyası nədir? 0. Y0 üzərindəki proyeksiyası nədir? Yenə 0. Deməli, yox, ümumiyyətlə, buradan görünür ki, şəkildən də görünür. Bu bizə tərəf gəlir, düzdür. Amma sağ qaydası ilə, baxın, sağ qaydasının X0 buradır, Z0 buradır, Y0'ımız aradır, şəklə doğru. Şəklin içinə girir. Bu isə bizə tərəf gəlir, Z1. Deməli, bu paraleldir Y0'a. Z1'imiz var, amma Z1'imiz paraleldir, deməli, Y0'a, amma əks istiqamətdə. Ona görə mənfi 1'i yazıram bura. Eyni şey biz burada da elədik, baxın. Z3'ün Z3'ü tapmaq istədik. Z3'ün üzərində balaca bir dənə unit vektor yapışdırdıq və onun proyeksiyasını tapdıq x0 üzərində və z0 üzərində və y0 üzərində. Bəs olan. Orada da biz nə aldıq? Deməli, üçbucaqlara görə, deməli, kosinüs 2-3 buradan aldıq. Buradakı bu yan üçbucağın bu katetinə görə də. Sonra bunu tapmaq üçün də sinüs 2-3 aldıq ki, bu proyeksiyasını, bu deməli z0 üzərində proyeksiyasını tapmaq. Baxın, nə yazdınız? Heç nə yazmamışsınız ki. Ha, bəli, bəli. Uzun, çox uzun olur. Farman, did you understand? Yes, you're welcome. I think this is the end of the class. Tomorrow at 9 o'clock, we are going to see each other. I mean, hear from each other. Have a good evening. I'll see you tomorrow.